Okay, so guys, we looked at all these lines with transversals the other day. Then we looked at triangles, and now we're going to look at polygons. Okay, so polygon is a simple closed figure formed by 3 or more line segments, something like a triangle. So polygons can be really any shape. It could be any random shape as long as all the lines touch, and those are called vertexes when they touch. I think you remember that from last year. But regular polygons have to be regular shapes, okay, which you guys are familiar with, like triangles, squares, rectangles, pentagon, hexagon. Okay? There's this thing called an interior angle sum theorem. And basically what it says is that the sum of the angles, interior, right, meaning inside, is equal to the number of sides minus 2 times 180. So if you don't want to write all that out, it's basically S for sum equals N for number of sides minus 2 times 180. I'm going to give you a little chart with some of them so you can make sense of this. But basically, if you have the number of sides, then you can get the sum of any shape. Okay? So let's talk about the 3-sided shape, which is called what? Triangle. You guys are smart. So if I take the triangle, which has 3 sides, right? I say 3 minus 2, which we all know is 1 by now, I hope, times 180 is going to equal 180. Okay, let's do the 4-sided, like square or rectangle. You guys already know, because you know square or rectangle is 90 degrees each corner, right? But here's the formula. So 4 sides is 4 minus 2, which is 2, times 180, so that's 360. Let's do the 5-sided, which is called what? Pentagon. Good. So this is found on what shape naturally? Anyone play a sport in here that has this on? No, not on baseball. What's a pentagon on? No one knows? Soccer. Who said that? Yay, Reagan. Not Regan.
Soccer.
Reagan. Soccer. Full of pentagons. So 5 minus 2 is 3. Times 180 is 540. Let's go on to the 6-sided, which is called what? Hexagon. Good. Hexagon. 6 minus 2, which is 4, times 180 is 720. Don't worry, you get to use calculators. Some of you are like, oh no. Some of these, though, I mean, you have written down, so you could just refer to. 7-sided. Does anyone know what that's called?
Polygon.
There's a song about the shapes. But do you guys know the 7? You don't know?
It's a hexagon.
Wait, raise your hand if you know.
Polygon.
So it goes triangle, square, rectangle, pentagon, hexagon, something, and then octagon. Who says septagon? Septagon. Do you remember this?
Yeah.
You learned this in what, 5th, 6th grade, I think?
Yeah.
Okay. All right. What about 8?
Octagon.
Okay, and then I didn't write down 9, but you guys know what a 9 starts with an N. Non-agon. Okay. So, and what's 10? Do you know 10? You do know 10. Okay. So here's some examples of how you guys will see this. It'll say something like, find the sum of the interior angles. Okay? And then they'll give you this, like decagon. And Sam was right. She said decagon is 10. So then you take that 10 minus 2 times 180 equals 1440. Okay? I just drew a little picture over here because my class yesterday needed some pictures so that they knew what interior meant, but I know you guys know, but there's a little picture. All right, hexagon is what? How many? 6. So 6 minus 2, we already have it up there. 720. And I drew a hexagon. Isn't that pretty? I know you're impressed. I didn't draw a decagon because I can't, but I did draw a triangle. I can draw triangles. All right, octagon is 8. So that's 8 minus 2 times 180. And 15 So basically after 10, it'll say like 11 agon, 12 agon, you know what I mean? It says the number, which is good. So that one's big. It's 2,340 degrees. Did anybody happen to notice like the pattern in the chart here? Like what is this going up by each time? What is it? 180. Good. Every time it adds 180. So that's easy, right?
Yeah.
Easy pattern. So this is just for the interior. Okay? Just for the interior. Use that formula every time it says find the sum of the interior. Anyone have an idea how, like if it said, give me one of the angles of a pentagon? How would you find just one? Yeah. Yes, divide it by 5, right? So you take the sum, divide it by 5, because there's 5 angles in a pentagon. Does that make sense? So if you just want to find one, and it only works for regular shapes. You guys got this down? No? Okay, I'll leave it for another second. But let's think about it. So if we have a regular shape like a triangle, you guys all know already you would divide 180 by 3 because you know equilateral is 60. So if you have any other regular shape, you just divide that by the number of angles, right? So that's how we get 90 degrees. And then for a pentagon, you said divide 540 by 5. So that's 108. Okay. So here's what you do, just in case you missed that. So to find the measure of each angle, divide the sum by the number of angles. Okay, that's what basically we just said. So a hexagon, for example, you would have 720. You divide that by 6, and that would give you 120. Does it work for every single shape? No, only the regular shapes. Because if you have an irregular shape, then you're going to have different size angles, right? They'll still add up to whatever it is, however many sides, but all the angles could be different. So to find the measure of each angle, divide the sum by the number of angles. The number of angles is also the number of sides, right? Okay, so that deals with just interior. So today you're going to do a little bit on interior and then a little bit on exterior. The exterior is even easier because exterior angles of a polygon, they always add up to 360. So I drew a pentagon, and then I just kind of extended each line, starting at the top. Okay. Kind of looks like, you know those little pinwheels that you put a stick on and stick in the ground? No? No one does this? Or you carry it around, when you blow on it and it spins. Kind of looks like that. Ah, childhood, right? Reminiscing. Back to the 80s.
It's like metal, and it's like shaped like a flower.
Yes.
A metal one.
A metal one. Kind of looks like that. Or those fireworks ones that spin around. All right. So remember, no matter the shape, the exterior angles will always add up to 360. Okay? So any shape, always 360. It's kind of cool. All right. So if you want to find one of these angles, what would you divide by? 360 divided by 5 on this one, right? So the other one, remember, it's like the total interior divided by the number. This is just always 360 divided by the number of angles. Okay? So I wrote that down. To find the measure of each angle, divide the 360 by the number of angles. But again, only works for regular polygons like triangles, pentagons, etc. Does anybody want to know why that works? Anyone care? So what happens if I have a line? What is the interior angle right here with 1? This is called supplementary, right? So that means this is 180 minus that. So I'll show you how that works. So if you take you take 360 and you divide it by 5. 72, thank you, Garrett. So that would mean all my exterior angles are 72. So that means this has to be 108, right? Because that's supplementary. 72 plus 108 is 180. And 180 times 5 equals 540, which is what we said was our, if you look back the page, for pentagon, it was 540. Isn't that cool? So 108 times 5 equals 540. It's kind of like working backwards. Just a little thing. You don't need to write it down, but if you want to know. Okay. Sorry. Okay, so to find the measure of each angle, this is only for exterior, divide the 360 by the number of angles. Are there questions? You just take my word for it, or what? You believe me that it works every time?
Sure.
All right. As long as you get an A, right? Okay. So I want you guys to do some practice, of course. The practice is 401 and 402. Okay? So I'll give you about 10 minutes to do these. You should use your notes because I doubt that all of you remembered all of that you just wrote down. So use your notes to do this.
Unless you just write it down, don't worry.
Yeah, right.